Procedure 1. Started by reviewing the list of equipment provided in the laboratory to familiarize ourselves with the tools needed for the experiment. Tip 4. Each piece of equipment. We spent some time observing and taking pictures of the tools to better recognize and remember their appearance. Three, we took notes of what each piece of equipment looked like, including its design, parts, and shape, to understand the basic structure of each tool. 4. We searched online for the basic applications, specific functions, and usage of equipment to deepen our understanding and confirm what we observed in the laboratory. 5. Lastly, we compiled and organized our notes and photos to better understand the purpose and role of each of the equipment.
This activity provided students with an opportunity to explore and understand the basic equipment used in fluid mechanics and hydraulics laboratories. Through the familiarization process, students were introduced to various instruments and apparatuses that are essential in studying the behavior and properties of fluids under different conditions. According to the study, hydraulic tools work using the force created by pressurized fluids, which allows machines to perform tasks and generate stronger force than pneumatic tools of the same size, because fluids cannot be compressed. This shows why hydraulic systems are commonly used in construction and heavy-duty work. Using these tools in the laboratory helps students understand how theory is applied in real-life engineering situations. In addition, Aligüe et al. 2022 found that students learn fluid mechanics better when they participate in practical and team-based activities. Hands-on experiments and group work help students stay motivated and understand concepts more deeply. Similarly, Garrett et al. 2020 reported that structured laboratory sessions allow students to connect theory to practice. These sessions improve understanding of fluid mechanics, principles, and build confidence in using laboratory tools safely. Overall, this activity helped students apply what they learned in class to laboratory work. It also improved their confidence in using equipment correctly and safely. By familiarizing themselves with these tools, students better understand the importance of hydraulics in engineering work. Teaching Flume has clear acrylic sides, venturi, sharp and broad-crested weirs, 2 vernier level gauges, an adjustable undershot weir, a crump weir, and a jacking system. HM 169 visualization of seepage flows, used to visualize streamlines in seepage and groundwater flow on different models using a contrast medium. FMEOO, Hydraulics Bench, allows the study of fluid behavior, hydraulic theory, and the properties of fluid mechanics. AFTUB, Fluid Friction in Pipe Space Unit, used to determine the friction coefficient in pipes of several diameters and roughness, to study the pressure losses in different types of valves and different fittings, and to compare different methods to measure the flow. HM 150.18 Osborne Reynolds. A glass container connected to various pipes for a water supply, water drain, and ink tank with an inlet pipe, used to display laminar and turbulent flows. HM 1509 horizontal flow from a tank has a transparent tank and a point gauge with scale interchangeable inserts, used to study and visualize the profile of a water jet. Theme 15, used to demonstrate and study the water hammer phenomenon in pipelines. Bernoulli's theorem apparatus consists of a one clear acrylic test section with the convergent and divergent part sections, supply tank, measuring tank, inlet water tank, and a pump for closed-loop water circulation with piezometer tubes attached to the test section.
Conclusion. In familiarizing the apparatus used in fluid mechanics and hydraulics, it provides an essential hands-on experience that creates bridge to the theoretical concepts with practical application. This enhances the understanding of the fluid behavior, system dynamics, and the measurement techniques, which are fundamental for designing and analyzing a hydraulic systems effectively. In mastering the use of this equipment, it provides the students and professionals with the skills needed to troubleshoot, optimize, and innovate within various engineering fields that involves fluid flow and its pressure management.